Hi everyone, my name is Sarah Ayling and I am a grad student at the Civil and Environmental Engineering Department at Syracuse University, and I work with Dr. Elizabeth Carter. Today I'm going to be briefly talking about quantifying vertical displacement of sediment nourishment sites using Sentinel-1 INSAR. So firstly, I want to give a little background on the importance of marshlands before I dive into INSAR. Approximately 40% of the United States population lives along the coastlines. These areas are being threatened by sea level rise, land subsidence, and more intense and frequent storms. One of our natural barriers for these events is marshes, beaches, and dunes. They are time and time shown again to be very effective at preventing a lot of costs from infrastructure and fatalities from these events. But the thing is, they have to be healthy in order to protect the community. The specific study area that I'm looking at for my project is the Scotch Bonnet marshland in New Jersey. This area was below optimal elevation due to sea level rise and a little bit due to land subsidence. So in order to combat this issue, the United States Army Corps of Engineers have placed sediment on this area to raise the elevation from unhealthy to a healthy level and improve the health of this marshland. So in October of 2024, they dredged about 25,000 cubic yards of material from the New Jersey Intercoastal Waterway and placed this material on about a 5-acre area of the Scotch Bonnet marshland. So the big question is, once we have the sediment placed on the marshland, how does this sediment evolve over time? And is the sediment placement actually effective? Does the sediment stay where it's supposed to, or does it spread out? And in order to get answers for these questions, it's incredibly hard and expensive to send people out to these sites over and over across time. But we are looking into assessing this issue with a certain remote sensing tool called INSAR. So what INSAR is interferometric synthetic aperture radar. So synthetic aperture radar involves shooting pulses of electromagnetic radiation from a satellite and bouncing it off the Earth's surface and receiving that bounce signal back. Using the known wavelength of these electromagnetic radiation pulses, we are able to assess the elevation from the distance from the satellite to the Earth's surface. What INSAR is it takes multiple of these synthetic aperture radar acquisitions, differences them, and you can create displacement from those differences. INSAR has been shown to have an incredibly high temporal and vertical resolution, and so we think that this can be very effective at looking at sediment displacement, small sediment displacement over time, because we're looking at the compaction and whether or not the sediment stays in this area. So with these sediment displacement measurements, we hope to take a bunch of them, put them together, and create a time series of displacement over time. So the main objectives of this project is to build an INSAR processing pipeline that generates vertical displacement time series for sediment enrichment sites. These are small areas of study that are in coastal areas, so we run into a couple challenges when building this INSAR processing pipeline. And then once we have that vertical displacement time series, we want to assess the accuracy of the INSAR time series against highly accurate LiDAR DEMs and also measurements that are taken on the site. Thank you for listening to my lightning talk. I look forward to talking with all of you at the Healthy Waters Conference.